Hey friends, I'm heading out on family vacation, so I made this video in case I missed the show. First, thanks to the camp staff and all the other campers for your knowledge, awesomeness, patience, kindness, and inspiration. Should any of you be in Boston, look me up. I would be honored to buy you a beverage. So I'm a professor at Boston College. I'm teaching our first physical computing course this fall, so my goal was to make many flashing things to show during our first module on microcontrollers and to use these examples to inspire student experimentation. So most of these projects are based on other projects, but my goal was to go home with lots of usable stuff. The most complete original project I made was this interactive mason jar light. After watching Lynn and Tom's presentation on light's benefits in healthcare, I wanted to make a playful light that reacted to a presence. Now, I'm not happy with the audio, and the animations could be a bit smoother, so reach out if you want to collaborate on improvements, but here's what it does. Turn it on and you get a pleasant startup sound and a brief flash to indicate that things are working. Now, I also use USB cables with built-in switches. This is often preferable to wiring an on-off switch. They're nicely tactile, and they simplify the build. Now, the box has an ultrasonic sensor. I used a US 100, which works with 3.3 volt electronics, and I don't need any resistors. Now, as you approach the box, some of the 20 neopixel lights in the light strand will light up in a random order, with the number and brightness increasing the closer you get to the box. Move away, and pixels are extinguished the further you are from the box, with an accompanying pop sound for each extinguished light. I'd like to line a bunch of these up in the hallway outside of my office, like Luminaria, and see how students react. To get the lighting effect, I used a simple mason jar. To hide the wiring in a neopixel strand, I put the light inside of a paper cylinder, then surrounded the cylinder with clear plastic beads that I got from a craft store. Now, once the cylinder was completely surrounded with beads, I slowly tore out the paper cylinder, leaving the lights inside the jar surrounded by the beads so you can't see the wires. Now, you could also make this with any microcontroller compatible with CircuitPython, and there's no reason why you can't modify this code with the Bluetooth code that I used in other projects, then turn this into a nightlight that will animate in a chosen color when not in motion sensing mode. Now, you could also build this with a breadboard, although I chose to solder the 4 wires onto the sensor. If you use a Circuit Playground Blueford or Express, you can avoid soldering onto the board and instead screw the wiring on using M2 screws and nuts. The sound can be from any RCA speaker attached to a Circuit Playground using alligator clips. And I designed this acrylic box using MakerCase.com, drawing in the holes for the sensor, the jar, the wiring, and the speaker using Adobe Illustrator. Thanks for your interest, thanks for watching, and hope we get to meet again soon.